Okay, folks. So I'm not sure if you had seen this example previously, but well, suffice it to say, I screwed up while doing so. I had a little bit of a brain fart, and I had misinterpreted the x bar and y bar that we're trying to solve for as if they were the distances from the x-axis and the distances from the y-axis, rather than what they actually should be, which is the location along the x-axis and the location along the y-axis. So our x bar is this, our y bar is this, if our centroid's located here. It's not actually located there, but anyways. So, my bad. Suffice it to say, yeah, instructors are not prone to making stupid errors sometimes. And one of the things I hate about teaching online and teaching via the videos is that usually when I do this in class, you guys notice and pipe up fairly quickly. But not the case this time, so my apologies. Anyhow, so we will go ahead and do this. So the way we go about this is kind of by breaking up the piece here into different sections and kind of adding and subtracting those sections. So I'm going to define the first section as this rectangle here. I could have done this rectangle here. I also could have maybe done this rectangle here and not included the triangle, this portion here. But either, you know, it'll work out in the end. So we'll start with that triangle, sorry, that rectangle. The next section that we're adding is going to be this semicircle right here. So we got that. Got the green. I'm going to put, and then we got the two sections that we need to remove. Now, essentially, when you're doing the math for that, it works out. You know, you treat it exactly the same, except you treat the area that you're using in the calculations as a negative value. So instead of adding area to the thing, you're subtracting area. And everything works out to give you the result you expect. So the first section we're going to be removing is this little triangle here. And next off, let's make this orange. Make that a bit fatter too. We'll also have this orange circle here that we're removing. So, and now that we've defined our areas, well, I mean, the steps that we need to follow are fairly straightforward but somewhat tedious. So what we're going for is we know that we can calculate our x bar, our big X bar. That's going to be equal to the sum of the x bar i's times the area for i's for all of the individual components that we're talking about, and then just divide that by the sum of the total areas. And that'll give us the location along the x-axis, the location along our x-axis here of the centroid. So I guess the first thing that we're going to want to do there is to calculate the areas, since we need to kind of add those up. So I'll start with a, so let's see, I'll just define our green section. There's one, our fuchsia, no, didn't actually select our fuchsia section there is 2. Our blue section down here, our negative blue section there is 3. And then our negative circular section in orange is 4. So let's go ahead and do that. So our A1 is going to be, we have 60 millimeters and we have 80 millimeters here to here. So those two things we can add together to get the height of the, A1 is green. Anyhow, so yeah, the 40 and the 60 add together to get our height. Sorry, the 80 and the 60 add together to get our height. So that'll give us 140 millimeters. And then we'll multiply that by the width. So that'll be the 120 millimeters. Which gives us, what does that give us? That gives us 140 times 120. 16,800 millimeters squared. So next up we're going to go for our fuchsia. So we've got our A2. So we know that the area of a circle is pi r squared. And we have a half circle here. So we're going to go with pi over 2 times r squared. So the radius of that circle from here to here is given as 60 millimeters, which is equal to pi over 2 times 60 millimeters, squaring that. And what's that give us? 60 times 60 times 3.1415 divided by 2. All right, 56, 55. Oh. Those. Okay. So we got our A1, we got our A2, A3. So A3, the base of that triangle is 120. The height of that triangle is 60. So the area, 120 times 60 divided by 2. And that's millimeters, and that's a millimeter. All right, so 120 divided by 2 is 60. 60 times 60 is just going to be 3,600. And that's millimeters squared. And, although I put that, it's A3, not A2. And then finally we've got our missing circle here. I'll go ahead and kind of specify here. So those are A3 and A4 are going to be negative areas, like I said. So I'll put that in that definition instead of just hoping to remember it later on in the calculations. So A4, again, pi r squared, no half because this is a full circle, not a semicircle. So pi times, it was 40 millimeters. Pretty sure, I'll double check. Yep, 40 millimeters for the radius. So 40 times 40, 40 times 40 times 3.1415. All right, 5,026 negative. Okay, so we got that. Next step up is just to go ahead and calculate what our xi AIs are. Sorry, our x bar I AIs are. So that's just going to be for this. It's relatively fairly straightforward. The location of the centroid about along the x-axis here, since we have the origin right here, it is going to be at 60 millimeters for all of these except for this 3 here. The only one that has any difference there is going to be that one, and that's because that's because it's a triangle instead of a rectangle. So its centroid is going to be, since we're going from a tip to base here, that'll be 2/3 of the way along here. So that'll be what, 80 millimeters. So we can just go ahead and kind of find out what this total sum here is. I'm just going to switch to green again. So we've got our x bar 1 A1. That's going to be equal to 60 millimeters times the 16,800. Okay, so 1,008,000. Millimeters to the fourth, to the third. Okay, next up we'll do our second area there. So x2, x bar 2, e2, that's just going to be, again, 60 millimeters times 56. So what are we looking at here? We are now 339,300. So our E for our third one, x bar A3. So that's the one that's going to have a different centroid. So again, 2/3 of the way, 2/3 of the way from this tip is going to be 80 millimeters instead of the 60 millimeters for the rest of them. So 80 millimeters, then times our negative 3600 millimeters squared. So negative 288,000. Millimeters, not fourth, cubed. And then for our fourth one, $60 millimeters for the centroid times the negative 5026. $301,560. Okay, so we got those values. One thing we're going to need to do is kind of add those up. So let's start with our area. So our area, sum of our area, that'll be, what we got here? We got 16,800 plus 5,655 minus 3,600, and then also minus 5,026. Okay, so, and then we just need to add up these values here as well. So we got too many zeros there. Okay, so that's and we're minusing these next two terms. Okay, so that gives us the sum of our x bar I AIs equal to 757, 740 millimeters to the third. And then we just use that to solve for our I bar. So I bar is just going to be this here divided by this here. So 757, 740 millimeters cubed divided by 13829 millimeters squared. Cancel that out. We're left with millimeters, which is exactly what we're looking for. We're looking for some sort of distance. We're looking for a distance along, a distance from the origin along the x-axis. So take that and divide by 13. Number lock is off. Okay. So we are left with 54.79. I'm going to just round that to 54.8. That's a decent spot to round it, I'd say. And so just looking at that here, so again, we know it's probably going to be fairly close to this center line down here, because the only thing that's causing it to shift is this little triangle here. And that little triangle here, it's a negative area that is mostly to the right of this kind of what would otherwise be this line of symmetry. So because it is to the right of there, it's going to cause the centroid to shift a bit to the left. So essentially, instead of being along this line, we're probably somewhere along that line. So that is that for our X bar. And the next thing we need to do is do the same thing for a Y bar. So we already have our areas. The areas don't change at all, so we can reuse those values. And you know what? I think I'm actually going to copy and paste them and then just stick them down there. Actually, no, that's a bit of a pain in the ass. I'll just rewrite them out. But so we've got our areas, and we just need to go ahead and find out what the sum of our Y bar AIs are, and that divided by the sum of our area is going to give us the Y bar overall. So the Y bar, again, that'll be the location of the centroid along the y-axis. So let's just go ahead and start calculating that. So we've got our Y1 A1. So that'll be equal to our Y bar for the green rectangle here. So that is going to be from the top or from the bottom. It'll be located, since the overall height of that is 140 millimeters. That'll be located at 70 millimeters from the top or the bottom. So from the origin here, that's actually going to be at 10 millimeters. So 10 millimeters. Again, that's a positive 10 millimeters because it's above the, it's from the origin, it's in the positive y direction. And 10 millimeters times our 16,800. And I'll throw my millimeters squared down there. So I'm not going to bother busting out the calculator for that. I just tack a 0 on there and make this millimeters to the third. Next up, our semicircle here. So for that one, I'm going to have to go bust out the charts. So just going back to our slideshow here. So we're looking at a semicircular area. And we've got this formula here. So it's a function of the radius. So 4r over 3 pi is the That's our y bar there. No, right there. 4r over 3 pi. Now the thing is, that's the distance from the centroid of this area to its base. So that's going to be from here to here. We also need to add to it 80 millimeters for the distance from where that base starts to the centroid. To the origin. So, y bar 2 A2, that'll be 80 millimeters plus 4r over 3 pi, and then just times our area, so 56, 55. I'm going to put this down here so I got enough room. Okay, so 4 times the radius of that section there is 60. 4 times 60 divided by 3 divided by pi plus 80. Or 3 pi, yep. So that gives us, so that's our y bar, 105.5 millimeters times 50. So that times so what do we got here? 596 407 millimeters cubed. So the next up, we need to move on to our third section. So we've got our y3 bar a3. So let's have a look here. We have the centroid of this cross section here. From this tip is going to be 2/3 of 2/3 of that distance there. So 2/3 of 60 millimeters is 40 millimeters. But again, we've defined our origin as this point here. So this point here is actually going to be a negative 40 millimeters based upon the fact our y-axis is increasing in that direction. So we do need to keep that in mind as well. So got a negative 40 millimeters, and we have our area, the negative 3,600 millimeters squared. So that basically just means that we got our negative signs there that cancel out, which means that basically removing sections below the origin shifts the is going to have the same effect as adding sections above the origin. Kind of it shifts the centroid upwards. So that gives us one gross thousand for 144,000 millimeters cubed. And then next up we've got our y bar 4 A4. So Y bar there, that one, it's kind of centered at the same spot as the top of the rectangular section, so it's 80 millimeters. Got 80 millimeters, and our area is negative 5,026 millimeters squared. So take those two, combine them together, and we get a negative 402,080. Not like the 80 really matters too much. We're gonna round down once we get to. we're gonna round down in a manner though once we or round in a manner that eliminates that once we get to the end. But so we got that, and we just need to find out what the sum of those are. So the sum of our yi bar ai's is going to be equal to, got the 168,000 millimeters cubed plus 596,408 plus 144,000 minus 402,080. So that ends up giving us a grand total there of 506,328 millimeters cubed. And then if we want to find our y bar overall, that's just going to be that divided by our total area. So 13,829. Millimeters squared. That cancels out. That gives us millimeters, which gives us a y bar value of 36.6 millimeters. Okay. So we got 36.6 and we got 54.8. So, okay, so that'll be, here's about the 40 line. So 36, probably right about there. And then the fit. So we're probably looking at about there for our centroid. Which, that seems reasonable to me, based upon the distribution of our masses. So that's how you do that properly. So yeah, like I said, the last time I did that, I screwed up not just the orientation. It turns out I actually screwed up when I was doing it. I forgot to keep track of the fact that the areas for the negative sections were negative. So I was just treating them as positive, and obviously that also really screws up your calculations. So don't do what I did there. And thanks.